Lecture 12, Pressure Conductory. This topic is types of the pi network start from the pi in series. From the previous classwork, 11, you have done on to solve the problem of the pi in series. Okay, and in this lecture, the pi in series can be solved by using the method of equivalent length. What is the equivalent length? The definition is two pi systems are said to be equivalent when the same head loss produce the same discharge in both systems. Okay, we start from the Darcy-Weisbach equation of head loss, and we substitute the V1 with Q and area, and so we can write equation of the head loss is function of the Q, and for second pi head loss is a function of Q2. Okay, based on this definition, 2 pi is to be equivalent when the head loss is equal and Q is equal. So we can make the equal equation between two head loss. And finally, we can write equation of the L2. In this case, we can say the L2 prime is shown in this figure. We have two sides of the diameter, D1 and D2, and L1 and L2. Next, we can convert from the D2 diameter into D1 using the L2 prime. Okay, to convert to use the equivalent pi method. Okay, the length of the second set of the pi is equivalent to the first set. Okay, we can look in terms of another. If we assume that if the D2 is D1 divided by 2, D2 is a half of D1, and F1 is equal to F2. So we can say that L2 is equal to L1 ratio of F1 F2, and D1 divided by 2 power 5 based on this equation, and L2 prime is equal to 0.331. Okay, just 3% of the L1. Okay. Next example. Solving the problem for pi in series using the equivalent pi method. Express the minor loss in terms of the equivalent length. Okay. The first step, we convert. This is minor loss K1 is about 0.91. So we can use the equation that this is minor loss when we make the equation equal to major loss. So we can write L1 is equal to K D1 divided by F1. Okay, so that is come from LE1. Okay, so we can convert from minor loss to the length is 21 meter, and in case of the pi number 2, K2 is 1, so we can convert to L2 is 66.7. Okay, so in this case, for F1, F2 is equal to 0.026 and 0.015, and the length of the first set diameter 600 plus the minor, we got the 321, and for the second pi, the plus the minor loss is we got 306.7. Okay, it's come from this is from the pi original length, and this is from the minor loss convert to the loss that is equal to friction loss. Okay. The next step, we express the 1 meter pi in terms of an equivalent length of the 600 millimeter pipe. So we just substitute that to find the equivalent length is equal to 13.76. So this means head loss for pipe diameter 1 meter is equivalent to head loss of pipe diameter it means head loss for the bigger pipes. You can say that the bigger pipe is a longer length, but is equal to head loss of the smaller pipe but short length. Okay. To find the discharge through the pipe, the 600 meter. So total length is from 221 plus the 13.76, we got 334. And this from darkness and capital H. So we can solve this equation to find the Q. Finally, we've got the Q is equal to about 0.8 cubic meter per second. So this means we bring together in just one per diameter and one at major loss. That is one equation that we can solve for Q. On the right hand side, just show the graphic that from the original 0.6 300 meter and the second pipe 1 meter and 200. The next step, we convert the minor loss to major loss. So we have to increase the pipe diameter to 321 and 306.7. And the next, we convert from 306 to be the 13.67, and the loss is equal to, from the length is 334. That is the for the pipe that is 0.6 diameter. The length is equal using equivalent length method is about 334.